Hello everybody, welcome back to another episode of Math with Mr. Emond. Today we're going to be finishing off our unit on absolute value and reciprocal functions. We're finishing section 7.4 on reciprocal functions, and today we're looking specifically at problems that involved finding or graphing f of x if you're only given the graph of g of x. And so let's try these out. So here's what we're given in this problem. Well, we're asked to graph f of x, and we're also asked to state the equation of f of x in the form y equals mx plus b. And so let's look at what we know here. Well, we're given this graph. And what is this graph? What pieces of information do we have? We have a vertical asymptote at x equals 2. They're giving us this point here, and that's probably for a reason. And so what do we know about vertical asymptotes? Well, vertical asymptotes are stemming from x-intercepts, right? So that's one thing. A vertical asymptote is an x-intercept of your f of x. So we have this point here that we know. What else? It's a non-permissible value. Okay, so it's a non-permissible value. And so that tells us that g of x might look something like this, 1 over x minus 2. And why x minus 2? Because when we set our denominator equal to 0, you get x cannot equal 0. And so we think it might be something like this. And if we were going to guess that, we would say, well, then f of x could be x minus 2. And you could try graphing that, right? You'd have this point here, and then you have a slope of 1. So go up 1, going through this point, and then going through this point, etc. And there you have a possible solution. But this isn't quite going to work. And the reason why this isn't going to work is because if we look at our point here that's given to us, this came from being a reciprocal value, did it not? This 3 1/3 was a reciprocal value of f of x. And f of x would have had to have been 3 and then the reciprocal of this, because only the y value actually swaps. What's the reciprocal of 1/3? It's 3. And so the reciprocal of this point actually belongs up here. This point doesn't exist on our graph. So to just assume that your slope is 1 would be a gross error on your part. Don't make that mistake. What we know is this point is 3 1/3, and the reciprocal of 1/3 is 3. So our new point becomes 3 and 3. And we know that this is an intercept. So this is where it crosses the axis. What else do we know? We know that the values where y equals 1, they're invariant points. And now you can see this is matching up nicely. And we have another invariant point here. Okay? So look for your invariant points. Those are easy to find. Look for your x-intercepts. Those are easy to find, right? Here's your x-intercept. And if you're ever given a point and it's very clear what that is, do the reciprocal of it, right? And I'm trying to look on here if there's any points that are easy to see, and no, right? They're all fractions and I can guess as to what they are. Nothing is clearly crossing into like a corner, like if there was a line passing through this point, that would be easy to tell what it is. It's 6 and -3. But we don't have any points like that are easy to figure out. And so we're dealing with what we're given. But now we know the slope. It's a rise of 3 and a run of 1. So rise of 3, run of 1. And then from this point here, down 3, left 1, down 3, left 1. And now I can figure out my whole graph. So now I can go ahead and create my line going through this point, passing through all my points, and there we go. So this would be my f of x. Okay, so what are going to be your key ideas for solving these? Well, first, we know that our x-intercepts are our vertical asymptotes. So whenever you see a vertical asymptote, that's going to be your x-intercept. The second thing, invariant points. Those are key points at y equals -1 and y equals 1. And they're going to help you just add points to your graph so that you can extrapolate your f of x from it. The third thing that you'll try to do is find points that you can easily identify. And those are to create reciprocal points. So for example, there's nothing easier to identify than something that's given to you. This is 3 1/3, which means the reciprocal of that would be 3, and the reciprocal of 1/3 is 3. Now, likewise, another thing that would be easy to identify is if you had a point that was exactly on an intersection. So this would be -2 and 3. It's easy to identify. And you can create a reciprocal out of that. If this was -2 and 3, then we would create a point at -2 1/3 for our f of x. And the last thing is find your slope and extrapolate. So here we could see that the slope was 3. And so we could plot in new points with that slope. And that is how you solve for these problems. Okay, let's move on. So here you go. Here's a problem. You're given, this is the same as we just did. You're given a graph and you need to find its reciprocal. Okay, so sketch y equals f of x given g of x here and state the equation of that line in terms of mx plus b. Remember, don't assume your slope. You have to find that. All right. When you're done, you can resume the video. See you soon. Welcome back. Let's go through the solution here. So there's a few things you should have noticed. The first thing is there's a vertical asymptote at x equals 3. Okay? And what does that mean? That means that that is an x-intercept right there. And then you have these invariant points here. And one thing that you should have realized is they're on these perfect points. This is 1, 2, 3, 4. This is the point 4 and 1. And this is the point 3 and -1. 2 and -1, sorry. This is the point 2 and -1. And so by looking at the distance between these points, you can find the slope. What is your slope in this case? It's 1, right? And so you didn't really need to extrapolate other points because we know m equals 1. And we know that there's an x-intercept of 3. And we can visually see the y-intercept here is -1, -2, -3. And that's really all you need, right? I can create the equation now. It's x minus 3. I could have also used this, right? Vertical asymptote at x equals 3 means g of x would have been something like this. And that means f of x would have been something like this. Now remember, there could be some factor out in front. In this case, there is no factor out in front, and this is in fact the equation. Good job. Okay, let's go ahead and figure this out. So what we're trying to do here is find f of x given g of x. And we're graphing f of x. And we're trying to place it in the general form or standard form of quadratic formulas. So let's get started here. So what do we know? We know that we have a vertical asymptote here and a vertical asymptote here. And what are those values? Well, this one is a vertical asymptote at x equals 2. And this one is a vertical asymptote at x equals 3. Now, what do vertical asymptotes tell us? Well, they tell us some very important information. One, that there's x-intercepts right there. Vertical asymptotes are x-intercepts. What other information do we have? Well, these are our invariant points. How do I know that? Because y equals 1 at this point and y equals 1 at this point, and there is no value at y equals -1, so I cannot call y equals -1 an invariant point. What else do I know? Well, I know that if these are my x-intercepts, then I'm going to have a vertex that is going to be somewhere around the middle of those two. And I'm going to go ahead and make another line here, somewhere in the middle of those two. There we go. There's my invisible line for where my vertex is going to go. And any guesses as what that is? Well, that's directly in the middle of 2 and 3. And what's in the middle of 2 and 3? Well, that would be an x value. So my vertex for my f of x, my x value is going to be 2.5. It has to be. It has to be in between my x-intercepts. And what is my y value going to be? Well, I can see here on this g of x graph that it had a y value of -1, -2, -3, -4. And I know that the corresponding point, the f of x point corresponding to this g of x point, is going to be the reciprocal of that. How do I know? Well, because g of x is the reciprocal graph. And what's the reciprocal of -4? It's -1/4. So all of a sudden I have my vertex, and I can try to put this in vertex form, right? Vertex form is y equals a x minus p, so x minus 2.5 squared plus q. So in this case, -1/4. And now we're in vertex form. And I can go ahead and graph this vertex. So there's my -1/4 there. And you might think, you might have enough points plotted here, Mr. Emond. You're probably good to go. But let's just finish solving this, because we know how to solve for a. Let's use any of these points that we know. Let's use this x-intercept here. So this point right here is 2, 0. This is one of my x-intercepts. What I can do is plug that into my vertex form equation and solve for a. So let's do that. 0 equals a, and then 2 minus 2.5 squared minus 1/4. Let's move 1/4 to the other side. So we have 1/4 equals a. 2 minus 2.5 is -1/2 squared. All right. Let's deal with this. So we're going to do -1/2 squared. Well, -1/2 squared is 1/4. So now we have 1/4 equals a times 1/4. Multiply both sides by 4. And the reason we're doing that is to cancel these out. And that leaves us with a equals 1. So there you go. A is 1. At this point, we're kind of golden, right? The fact that a is 1 tells us that, well, remember, a in vertex form is the same as your a in your standard form. And of course, another thing we know is that these vertical asymptotes are our x-intercepts. And so we have x minus 2, x minus 3, and our a value is 1. And so there's nothing multiplying these. It's just this. And so now we can get our equation. So we have x squared minus 5x plus 6. All right. That's fantastic. That was easy. So we have x squared minus 5x plus 6. What does this tell us? Well, we have a y-intercept of 6, which means this point is also 6. And now we definitely have enough information. So it's going to be rising up over there passing through these points, coming back up, and there we go. There's our f of x. And of course, red is our g of x. Now, one thing to note, if you wanted to continue on with this one, you could have, right? You could have said input the 1, and then x minus 2.5 squared minus 1/4. And you could have done this, right? Let's complete this. So we have x minus 2.5 times x minus 2.5 minus 1/4. This is going to lead to x squared minus 2.5x minus 2.5x, which is going to be minus 5x. And 2.5 times 2.5 is 6.25. So plus 6.25 minus, let's call this 0.25. And there we go. That's going to bring us back into y equals x squared minus 5x plus 6. So hopefully you see, this was a shortcut, right? Well, as soon as I realized that a was 1, then I could just use these to solve for the equation by putting it in factored form. This is factored form, and then factor it out, and it's going to give me standard form. If you're not comfortable with that, of course, you could go back here, right? And just plug in your a value and start solving. Expand it out fully and you will get the exact same answer. So whichever method you prefer is fine by me. Go ahead and try this out yourself. So what you're doing is graphing y equals f of x and telling me the equation in standard form given this graph that you have here. See you soon. Okay, welcome back. Let's go through the solution. So what I did here is first I found my vertical asymptotes. So that's these dashed green lines here. And my vertical asymptotes were x equals -1 and x equals 3. And I remembered, well, vertical asymptotes, they actually imply non-permissible values. They're also my x-intercepts, right? So I could immediately plot these points here. And I'm gonna actually make those dots a little smaller. My x-intercepts would be these points here on the vertical asymptote. But I also remember that they imply non-permissible values, meaning I can plop them down here into my g of x equation and then expand this out, and I would get 1 over x squared minus 2x minus 3. And I'd remember that g of x is equal to 1 over f of x, and that leads me to this equation here, x squared minus 2x minus 3. Now, I have to be a little bit careful, don't I? Because this equation is operating under the assumption that my a value is 1. And do we know that my a value is 1 definitively? Not yet. So this could be the equation, but we're not going to lock it in just yet. We're going to do a little bit more of an analysis of our graph. So what other points do we know for sure? Well, we have invariant points whenever y equals 1. And so there's 2 invariant points there. And we also have invariant points when y equals -1. So there's invariant points here. So already there's 6 points that are locked in on my graph that I know belong to f of x. And I'm starting to get the overall shape of it. But the question becomes what's happening in this section. And what I know is that I have an axis of symmetry at x equals 1. And how do I know that? Well, if I have a x-intercept at -1 and an x-intercept at 3, then in the middle of those 2 points is x equals 1. And so that's my axis of symmetry, which means my vertex is going to be lying on this point. Now I could try to look at this point here on my g of x graph and do the reciprocal of that. So we can try, but this, it's super hard. Like, what is it? Is it 1/5? Is it 1/4? I just don't know. I can't really guess what that is. And so that's kind of not a good strategy to use. So let's just try some other strategies to try to figure this out. Well, if I am to consider that this may be true, my a value might actually be 1, what happens when I plug in an x value of 1? Let's do it. So we would have y equals 1 squared minus 2 times 1 minus 3, which would mean y equals 1 minus 2 minus 3, which means y would equal -4. Okay. So that would mean I have this point here when x is 1 and y is -4. It's possible, right? This could be 1/4, which would make this 4. It's possible. I could tentatively put that in there. And then I might want to see what my y-intercept could be. Now I can see here this, I don't know whether this is 1/3 or 1/4 or 2/5. Like, I can't guess that, right? So let's see. What if it was a value of 1? Well, then similarly, I could plug in x equals 0. And here I would get y equals -3. And that would be this point here. And then I would have on my axis of symmetry a similar point. Now let's see if this actually works out, doing some logic. If my x value was 1, then it would be a graph of this form, which means that from my vertex, my next point would be over 1 and up 1. Is it? Yes, it's over 1 and up 1. Okay. My next one would be over 2 and up 4. Is that over 2 and up 4? Well, 1 over 2 and up 1, 2, 3, 4. It is. Interesting. My next one would be over 3 and up 9. Is this over 3 and up 9? Well, this was 4, 5, 6, 7, 8, 9. So it looks like it worked, right? We couldn't really solve mathematically that a equals 1, but by plotting in the points, so I'm just going to erase some of these track marks here. By plotting in, I'm going to go to my highlighter. By plotting in the points that would arise if a was 1, and then seeing what happens from this point on, we could see that a equals 1 does in fact work because it passes through the known points that we have identified earlier, these 6 known points. And so we can definitively now say that the answer is f of x equals x squared minus 2x minus 3. Hope you enjoyed watching. That's the end of this unit. See you next time. Bye-bye. Hey everybody, you can like, follow, and subscribe to my social medias right here to get notifications as soon as new content is uploaded. This video concludes our learning unit. You can find the playlist this video was in right here and click here for the next unit that we'll be covering. Thanks for watching and keep learning, everybody. Bye-bye.